Hi, hello everyone. Today I am going to start a new session on the principles of artificial intelligence. In that, yes, we are going to see defining the problem as a state space search. Okay, it's nothing but simply the searching techniques. So various searching techniques are available in the artificial intelligence. So what is in that? Just in that what we are going to specifically we are going to do search some particular problem statement. How we are going to select some. A solution from the various problem statements. So this is we are going to see in this video. So let us start. So from this, just we are going to see the set of things. That is one is state space search, and the second one is search techniques. So various search techniques are available to search some problem statements, some specific solutions, and then the last one is various properties of searching techniques. Okay, just if you having various searching techniques, just we have some certain properties. Okay, so various components we have to follow. So you have to keep in our minds of these things. Just we will see in that the various properties of searching techniques. And then we will see one by one. The first one is state space searching search. Okay, so is nothing but some searching techniques. Okay, searching algorithm. This already we know that various search algorithm is available in the day-to-day in our field. So in that, what specific searching algorithm, what specific concept we are going to choose for based on the problem statements. Okay, selecting the some specific solutions. So we are going to take some specific algorithms. Alright. So in that, just we are going to see that one. Just we are what is the exact meaning of the state space search? Just it is whatever. Just we are making some or designing some devices for solving some particular problems. So we got to think with so certain concepts. Okay, so to build a system to solve a particular problems. Okay, so already said. So for what to build a system to solve some particular problems, so we must to know this. We need to do some things. Okay, so what are the things that we are going to do? The first one is define the problem. Okay, so what is it? Define the problem. Just if you are having some problem statement, first we should understand what is the specific problems are going to be. Okay, how we are going to solve the particular problems. How we are going to reach the some goal state or some reach the some appropriate solution or optimal solutions. Right. So first we have to define the particular problem. So what is the problem statement? So how we are going to do? In which way we are going to search for collecting the necessary data? Like this, just we have to do first. Okay, that is defining the problem. Okay, the second one is analyze the problem. So what is the analyze the problem? Just we have some data. Okay, regarding our problem statement. Now we are going to analyze how the data or some specific information or some specific algorithms, how it will be used to reach the goal or to produce some optimal solution. That way, just we are going to analyze the some specific problems. Okay, the third one is identification of solutions. Okay, so now we have some ideas. We have some enough data. From the data, yes, we are going to do some pre-processing or some accusing. We are getting some related data. Okay, so from the data, okay, if you are using that data, okay, in the time consumption or space consumption due to some time consumption, space consumption, we have here various output. We have here some optimal solution or actual solution, some appropriate solutions. Okay, so that way just we are going to identify some solution regarding your problem statement. That was here identification of solution. The next one is choose the best solution. Okay, so we have here 4 set of solutions. Okay, so from this solution, just I am going to choose the second one is the best solution for the particular problem statement. Okay, so it is a nearby goal state. Okay, the second state, the second one is here. The second solution is the setting the goal state. So now we're just I'm going to choose the second one is here the best solution for the your problem statement. That way, just I'm going to choose the best solution from the set of solutions. Okay, so after finding the some solution, just we have to implement. Okay, using some various techniques, various operations. Okay, various specific languages, some or tools or some specific platform. Just I'm going to use to implement the particular data based on the particular problem statement. Okay, so it's a common word. So implementation is a common word. Whatever just you are choosing, you are collecting the data. So after completing all the process, using some specific operations, we are going to implement. Okay, we have some kind of code for particular problem statement. Just we are going to implement in a particular platform. So, for example, in Java, just JDK, just we can use for C, Turbo C, we can use or Python, just some ideal versions we can use based on the problem statement. So, it is a implementation. So, before going to start that analyze, we are going to take the definition of the problem, analyze the problem, identification of solution based on that particular problem statement. Okay, from again we have to choose some best solution from this set of solutions. The last one just we are going to implement based on that collected data or collected solutions, some appropriate solution or optimal solution. Then we will see the whether that algorithm or such techniques it will produce some optimal solution or actual solution or exact solution based on your problem statement. So these things just we have to keep in mind before you are going to start a or build a system to solve some particular problems. Okay. The next one, just we will see the one example for solving the real-time world. Okay, so this one is 8 Basel problem. Everyone know that 8 Basel problem. So what is the 8 Basel problem? Just we are having some initial state. Based on the initial state, just we are going to take some specific operation or specific technique. Using some specific techniques, we are going to solve or we are going to produce some goal state. Okay, from the initial state. That was the 8 Basel problem. Okay, so again we can take any type of problems as a traveling salesman problem. We can take a 8 queen problems and n queen problems. We can take any kind of problems to take this searching techniques. Okay, so now we will see the some 8 Basels problem. Okay, here we having one initial state, we having the number of state. We have to arrange all the numbers in a sequence of manner. Okay, here the initial stage will be considered as here some 3 into 3 matrix. Okay, so 3 into 3 the matrix. Now we will take the 3 into 3 matrix. In that, just totally 8 sequences there. That we have to arrange it as in a sequence of manner. Okay, in order we have to do that one. Okay, so this one is considered as a initial state. Okay, so here just I am going to do some or perform some specific operations. Okay, just we have a number of operations. So here I am going to take just we have to do some upwards. We have to move to the upwards or otherwise downwards. Okay, here left, here right. Okay, so here now I'm going to perform some specific operations up and down and right and left to move. Okay, so I'm going to do some specific operation to reach the goal state. So what is the goal state here? Just so finally after completion of the specific operations, the AI machine or AI system should be produce the this optimal solutions, right? Actual solution. That is a goal state. Okay, so now I'm going to take the first step. The first step is the upwards. Just we have to move the blank page. Okay, which one we are going to move? The blank page we have to move to the upwards up operation. Okay, here if we are moving this blank page to up means the 3, 2, 4, 1, 5, 6, 7, 8. Right? So this one is I'm using the upwards operation. The next one is downwards. Okay, the second operation is this downwards. So this specific empty place just I'm going to move the downwards. Okay, so if it is so, 3, 1, 2, 4, 7, 5, 6, then space and 8. Okay, so this one is after applying downwards operation, the output will be produced like this. Okay, the third one is we have to move to left. Okay, just we have to move the left, this empty space we have to move to the left side. So if it is so, 3, 1, 2, 4, 5, 6, 7, 8. So this one is a third operation, that left to move. Right, we have to do the left to move, the blank space I have to be move to left. Okay, the fourth one is the right operation. Okay, right operation, that is right move. Okay, so just the specific empty space, just we have to move to right. So if it is so, 3, 1, 2, 4, 5, then empty, then 6, 7, 8. Like this. Now just we perform some specific operation based on that initial state to reach the goal state. Okay, now just each and every state. Okay, this one is state 1, this one is state 2, this one is state 3, this one is state 4. So now we have to compare each and every state to the goal state. Okay, so now I am comparing the state 1 with the goal state. So if it is so, 3 space 2, 1, 4, 4, 1, 5, 6, 7, 8. So this is not some optimal. It will not an optimal solution. It will not reach to the goal state to the next step. Second one is the state 2. Then again it will not produce the some optimal solution. The state 2 also will not produce some optimal solution. Okay, then next state 3. I'm going to compare with the goal state. Okay, if it is so, then 3, 1, 2, 4, 5, 6, 7, 8. So if it is so, just state 3, it will be considered as some after next one move, it will produce some goal state. Right? If it is moving that 3 to the downwards. Okay, so the second operation, if you are performing the second operation, what is the second operation? Down move. Okay, so if you are doing that down move operation on the state 3, it will reach the goal state. Then again one more state is there, the state 4. So again you have to compare with the goal state 3, 1, 2, 4, 5. Here it is empty space is there, 6, 7, 8. So if you are moving that empty space to any specific operation, right or left or down or up, we can't do to reach the goal state. Sorry, just we have to move upwards. Okay, sorry, I already said in the downwards. No, the state 3, that empty space will move to the up. Okay, so here we have to going to perform the up operation, move up. Right. So this one just we are going to take. So if it is so, so now I am going to perform up. Okay, just I am going to use move up operation. Okay, so from the state 3. So if it is so, the empty space will come here, then the 3 will come here, then 1, 2, 3, 4, 5, 6, 7, 8. Right? Now you got it, right? So this one is here goal state of your problem statement. Right? So from the initial state to the goal state, just we are going to do some specific operations. Either we can take any kind of operations based on the searching techniques. Then we can take any kind of operation. Here we consider up and down and more left and right. Okay, so based on that one, just if you are having a different, it will produce a different state. Okay, so identification of this one is here. The first one is the problem definition. What is the problem definition? Is the 8 bustles problem just we are going to solve. Okay, well, we have to consider that initial state. So like that we are going to define the particular problems. Okay, the second one is what is some analysis of the problem. Just we are going to analyze, okay, from this initial state how we are going to solve the particular problem statement to reach the goal state, right? If it is initial state to reach the goal state, just we are going to take some specific necessary operations like up and down operation and right, move right and left, okay, like that we are going to analyze this. Okay, the next one is the identification of solution. Okay, here we have a different state, right? State 1, state 2, state 3, state 4. All the states are made from the initial state. Okay, so we have the different solutions. So which one we have? This one is the identify solution of state 1, state 2, state 3, state 4. Okay, from this now we are going to choose the solutions. Okay, which one? Which state is here? If you are taking that, it will produce the optimal solution or actual solution or exact solution. Okay, so the state 3 is here. It will suitable for to reach the goal state. So we are going now we are going to choose a state 3 as here to produce some actual a solution. Then we will perform some operation on the particular state 3. Then we will reach the goal state. Okay, what is the goal state? 1, 2, 3, 4, 5, 6, 7, 8. It's like that. We have to in order just we are going to do some operation to reach the goal state. Okay, so this one is the 8% problem to produce some searching techniques, some specific examples, right? It's clear, right? Okay, so next we will move to the some searching techniques. Okay, so various searching techniques is there already. We know the two types of searching techniques is available in artificial intelligence, right? So the first one is informed search. Okay, the second one is uninformed search. Okay, so here just before seeing the various types of informed search and uninformed search, just we will see what is informed search and what is uninformed search, or what is going to be how it will be search as a particular the problem statement with the help of some informed search and uninformed search. Okay, so here this is the informed search is also called as a heuristic search. Okay, so it's a familiar word. The heuristic search is also called as a informed search. The uninformed search is called as blind search. Okay, or brute force search. Okay, just the familiar word is a blind search. Okay, so the other name of the informed search and uninformed search. Informed search is a heuristic search. Then uninformed search is a blind search. Okay, because the informed search it will produce the optimal solution. Okay, so in uninformed search it will produce the exact solution. It will guarantee to give the exact solution, actual solution for the informed search. Okay, so first one is the first point is record information to perform the search. Okay, we need to some information. Okay, we need some information to search some problem statement. Okay, if you are using that informed search, we need some information. We need some data to search the what is the exactly problem statement is going to be defined. Okay, so now it comes to the uninformed search. Do not record any information to perform the search operation here. Okay, so we don't need to any information. Okay, if you have the problem statement, directly we going to define the problem and analyze the problem, identify the problem, choose some solutions, and finally just we are going to implement. So that is in uninformed search. No need to any information to perform the search concepts. Okay, the second one is based on this required information, it will reduce the time complexity. Okay, because already we know that we have some enough information, enough data. Okay, based on that we are going to do some perform some operations, right? So we no need to more time. So it will reduce the time complexity is very less if you are going to choose informed search concepts. Okay, here increase the time complexity is the probability of the time is more. Okay, so time will be increased because we don't have any information. Okay, then we have to take more time to define the problems based on the problem statement. Like that we are to do that, right? So we need some more time to do some searching operation in that concept. Okay, uninformed search. Okay, here good solution accepted as optimal solution. Okay, so it's a very important one. Okay, good solution. The good solution means whatever that search engine will produce, okay, that will be accepted as a solution. Okay, that optimal, that results, that solution, it will be considered as the optimal solution. Okay, there is no guarantee that is the exact solution, that is the exact goal state of the particular problem statement. Okay, so if you are using the informed search, there is no guarantee of optimal solutions. Okay, the third one is here the best solution can be achieved. Okay, here the guarantee is there whenever you are using that informed search, it will give the exact solution. All right, that is a very accurate solution for the particular problem statement. Okay, so here it can handle large search problems. Okay, we have the some enough information, enough data, then we can go for the large search problem also. But here the impractical to solve a large search problem. Okay, because we don't have enough information, enough data. If it is so impractical, just they can't go for the large amount of data such problems, right? If it is so, it will happens means it will increase the time. The time complexity will more to execute to complete the particular or to solve a particular problem statement if you are using the uninformed search. Okay, the next one is the last point: less cost and more efficiency. Okay, informed research means we have enough data. Okay, based on that it will go for the further operations. So the less cost. Okay, already information is there, so no need to collect any information. So we are going to do some specific operations. Okay, so the more efficiency. Here the more cost, less efficiency. Okay, the more cost means we don't have information. Okay, we need to collect the information. So the cost is also is more. So the efficiency also is less. Okay, so some specific operations is going to be performed if you are using the informed search or uninformed search. So based on that one example, A star search, best for search, O star search is here the best example searching algorithm for informed search. Okay, here uninformed search we having a BFS, a DFS, and a bidirectional search. There are hill climbing. Alright, so here is a BFS means breadth first search and depth first search, and a bidirectional search and a heuristic hill climbing. Okay, on a traveling salesman problem like that, just we can take any problem or any searching algorithm, the best algorithm for both informed and uninformed searching concepts. Okay, so this is the exact meaning of the informed and uninformed search concepts. There is a two types of searching algorithm or searching techniques. There is a informed search, uninformed search. Right? If you are choosing the informed search, how it will be produces some optimal solution. How it will be the cost, time complexity, space complexity, and the efficiency. How it will be we can see. Then after that, uninformed search. If you are using the search problem statement, if you are using the uninformed search algorithms, then how it will be data and how it will be produce some optimal solution, how it will be time complexity and space complexity, and how it is the efficiency and all we can see in that uninformed search. Okay, so these are two types of searching techniques, informed and uninformed. Okay, so next one, just we will see the what is the exact searching algorithms available to solve some particular problems using the machine learning, artificial intelligence. Okay, then we will see each and every one in detail by the next video, right? So the first one is that is uninformed search. The second one is informed search. In the previous slide we can see what are the types of searching algorithm, right? Uninformed search is a blind search. Already said uninformed search is also called as a blind search. Okay, here that informed search is called as heuristic search, right? Here the informed search is also called as a heuristic search. The uninformed search is also called as a blind search. Okay, so in the uninformed search, just we have the various types. Okay, the breadth first search. Okay, the BFS and the DFS and unique cost search, depth limit search, iterative deeping depth first search. Okay, bidirectional search. Okay, we have used various search algorithms are available under the uninformed or blind search algorithm. Okay, here in the informed search, the best search and the A-star search is the best example, the best algorithm for finding the solution. So based on the problem statement. Okay, here we have some additional algorithms: A-star search. Okay, hill climbing, etc. Okay, just we can write the we can choose the best algorithm as my informed search is the best for search and A star search, right? So this is the various types of searching techniques. So we have two types of searching techniques: informed search and uninformed search. In that, what are the algorithm, best algorithm we are selecting if you are choosing that uninformed or informed search based on your problem statement, right? Okay, then the last topic is the properties of search techniques. Okay, various properties, that is the properties in the various components, various things that we are going to consider in that searching techniques. If we have the problem statement, just we are going to use some searching algorithm. So what are the things we have to keep in our mind? Okay, the essential properties to search algorithm to compare the efficiency. Okay, for what we are going to take some several properties in searching techniques means we have some efficiency, right? Efficiency is nothing but is a time and space complexity. Based on your problem statement, okay, it will produce some actual output or some optimal output. Okay, then we have to compare the efficiency with the problem statement or based on that algorithm. If it is so, we have different properties. The first one is the completeness, optimality. The third one is time complexity, and the fourth one is space complexity. Then we will see one by one. So, what is the completeness? In the search techniques? Okay, if you're having some problem statement, we have to give the exact clarity. Okay, in the previous search I said that we have here different few things that we are going to keep based on your problem statement. Okay, the first one is defining the problem. Okay, the second one is analyze the problem. Okay, identify the solution. Choose the best solution. Then implementation. Okay, so whichever you are going to take the problem statement, that should be defined very clearly. Okay, if the third person also, they can understood what is the problem statement. Like this, you have to give the complete problem definition before you are going to start the finding the solution, right? So the search algorithm is said to be complete. It guaranteed to return a solution if at least any solution externally for any random input. Okay, so what are the input, what are the data, what are the information you are going to gather from search engine based on your problem statement, that should be complete. Okay, we should not give the incomplete definition to the machine, artificial intelligence machines, right? So there is a completeness. What are the problem statement you have? You should give the definition for the problem statement is a complete manner. Okay, there is a completeness. The next one is optimality. Okay, so it is a solution. Just it will produce the exact solution or some optimal solution based on your problem statement. Okay, if a solution found for an algorithm, it's guaranteed to be the best solution. Okay, lowest path cost. Okay, the best solution means the lowest path cost. So the time complexity or space complexity should be the very less. Okay, so that the best solution it should be produce. If you are selecting some specific algorithm based on your problem statement, that algorithm should be produce some optimal solution or exact solution based on your problem statement. That is some optimality. Okay, so among their all other solutions, then such a solution is to be a optimal solution based on your problem statement. Okay, so the next one is time complexity. Okay, everyone knows that what is the time complexity? It's a running time. It is some programs or some machines will take the recorded time to execute the particular program code. Okay, so the same thing, the time complexity is a measure of time for an algorithm to complete this task. So if you have a problem statement, okay, to solve it, to reach the goal state, how much time it will take to reach the goal state, or what the time required to produce the actual solution based on your problem statement. There is a time complexity. Okay, time required to solve a problem. Okay, the next one is space complexity. Space complexity is something how much space is required, how much storage, how much memory it will be required to store all the gathered information or gathered data. Okay, so it is a maximum storage required at any point during the search. Okay, if we are having some problem statement, we are going to first define the problem. Okay, if it is a problem defined, we are going to take some search. We are going to take any techniques to search some particular problems, right? So if it is so, how much space it will be? Okay, if you are gathering some information or gathering some data, okay, in your machine, how much memory it will be needed? Okay, if you are having a plus b equal to a square plus b square plus 2ab. Okay, so this one is one entire data. Okay, so in your machine, if you want to store this particular expressions, okay, how much memory, how much space it will be needed in your machines. That way, it should be depending the space complexity, right? So this is some basic concepts of the searching techniques. Okay, so what is the state space search and what is the various searching techniques available to solve some particular problem to produce some optimal solutions. Okay, so what is the different components or different properties or categories of searching algorithm is available, we can see. Okay, in the next video, just we will see another concept. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.